Hello. Today we're going to be talking about symmetries of functions. Symmetries of functions are going to be used a lot in your later calculus classes, and the trends that you're going to learn today will be beneficial for that, and they're also useful in the physical world, especially in physics classes. To begin with, we'll just start with an easy example. So if we look at this function of f of x equals x squared, then we'll see that at any given point of a, it's symmetrical across the y-axis to a negative a. So given that, we know that this is an even function based upon the fact that it's symmetrical across the y-axis. Other even functions include any polynomial raised to an even power. So we could have x squared, x to the 4th, x to the 6th, etc. Or we could have even or constant functions such as f of x equals 2. Now these are all even functions. If we look at this example of f of x equals x squared, then we can come up with a rule for even functions. And the rule states that if f of x equals f of negative x, then f of x is an even function. Now we can break this apart into even smaller rules, smaller trends. The first rule we'll say is that if we have even functions added together, such as f of x equals x to the 6th plus x squared plus 1, then we know that this function is an even function. Or if we have multiples of even functions added together, such as f of x equals 5x to the 8th minus 3x squared plus 4, this is also an even function. And on our third rule, we can say that ratios of even functions will exist as even functions. So, for example, this is also an even function. Now, we've learned that even functions are just that, even functions whenever they're symmetrical across the y-axis. But what happens whenever we have odd functions? So an odd function you're going to see as symmetrical across the origin. So if we have another function So when we look at this function, we can notice that it is symmetrical across the origin. No matter how we rotate this, it's always going to be symmetrical at the origin. So from that, we can come up with a rule of odd functions. The rule states that if f of x or f of negative x equals negative f of x, then the function just like our even functions, we can come up with more simple rules such that you'll see in your different calculus classes. Our first rule, like our other, is that any function, any polynomial raised to an odd power, it's going to be an odd function. So again, just if f of x equals x cubed, or f of x equals x to the 5th, all of these functions raised to an odd power are going to be odd functions. Okay, so just like our even functions, if we start breaking down our odd functions, we can start to notice other simple rules. For example, whenever we have our additive or our multiple rules of f of x equals x to the 9th minus 3x fifth minus x, we know that this is an odd function. Okay, so what if we have an even function plus an odd function? An easy example of that would be f of x equals x squared plus x plus 1. So here we have our even function and here we have our odd function. So is the answer going to be that the whole function is even, symmetrical across the y-axis, or odd, symmetrical across the origin? So let's just plug in a negative x. If we do this, we'll see that we get and when we simplify this, our answer for f of negative x is, and when we look at this, we can notice that our function is neither even nor odd, such that negative x does not equal f of x, and negative f of x does not equal. So we notice that if we have an even function plus an odd function, we get neither even or odd functions. Okay. So for the last examples, we'll look at what happens if you multiply even and odd functions. So say we have f of x equals x to the third times x to the fifth. When you multiply these two functions together, as you know from your exponent rules, we're going to end up with f of x equals x to the 8th. So we notice that if we multiply two odd functions, we're going to get an even function. Now what happens if we multiply an odd function times an even function? When we multiply an odd times an even, our answer is going to be an odd function. And then when we multiply two even functions, we end up with an even function. And that would be the same for dividing even and odd functions as well.